Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about full subtractor. Full subtractor is also a one type of combinational logic circuit. Before we start understanding full subtractor, we should know the necessity of the full subtractor. In case of half subtractor, we know that we can subtract two binary bits at a time. But in case of multi-bit subtraction, and if we have borrow from the previous stage, then simultaneously to subtract three binary bits at a time, that is not possible in the half subtractor. To overcome this limitation, we have to use full subtractor in case of multi-bit subtraction. Let us start with the block diagram. We have block diagram for the full subtractor. At the input side, we have two binary bits A as well as B, which is used for subtraction A minus B. At the same time, we have a possibility for the third terminal also in full subtractor, and that is B in, that is a borrow from the previous stage. And we have a difference, that is D, and final borrow, that is B out. So in case of a full subtractor, we have three terminals at the input side and two terminals at the output side. Full subtractor is nothing but a combination of two half subtractor. We can understand the block diagram more easily if we use two half subtractor. Now block diagram with two half subtractor. We have half subtractor 1. We give input, that is A as well as B, and we use half subtractor 1 to get the difference A minus B, and we use the second half subtractor. We give the difference output of the first subtractor to the second half subtractor, and at the same time the borrow from the previous stage that we give as one of the input to the second half subtractor. So we have difference D from the first half subtractor, and we have borrow from the previous stage, and the difference output of the second half subtractor is taken as the final difference output D. At the same time, we use one OR operation. We give borrow output of both the subtractor to the OR gate, and if any of the half subtractor is generating a borrow, then through the OR gate we have final output, and that is a B out. So this way, with the help of two half subtractor, we can very easily understand the operation of the full subtractor. Still, if we emphasize the block diagram of the half subtractor with the realized circuit, to understand the block diagram of the full subtractor will be more easier. We have first half subtractor and we have second half subtractor. In case of half subtractor, we know that we use one exclusive OR gate and one AND gate, and one of the input of the AND gate, that is inverted. Now we give input A and B to the first half subtractor and as the input of the exclusive OR gate, and A minus B, that difference D is generated, and that is given as a one of the input to the half subtractor 2. At the same time, we give the borrow from the previous stage as a one of the input to the half subtractor, and final output from the half subtractor 2, that is difference from the A and B as well as from the borrow of the previous stage, and that is taken as the final output, the difference D. At the same time, we use one OR gate. We give borrow output of both the half subtractor to the OR gate, and output of the OR gate gives final borrow, that is B out. So with the help of a realized block diagram of the half subtractor 1 and 2, it is very easy to understand the operation of the full subtractor. Now let us start with the truth table. A, B and B in, that is a borrow from the previous stage. We have 3 input terminals and difference and final borrow, that is D and B out. So we have 2 terminals at the output side. Now in case of 3 input combination, we have different 8 possibilities of the input combination. So we take A and B either 0, 0, 0, 1, 1, 0 and 1, 1, and with each possibility we first take previous borrow either 0 and then 1, and we'll check the output difference as well as borrow. We have first condition, that is 0, 0, 0, difference 0 and borrow, that is 0. We have second condition 0, 0, 1. So 0 minus 0 minus 1. So we have difference 1 as well as borrow 1. Then second condition 0, 1. First with the 0 previous borrow, 0 minus 1 minus 0. So again we have difference D1 and borrow, that is also 1. 0 minus 1 minus 1. So difference 0 and borrow, that is 1. Now next condition, that is 1, 0. First with the 0 previous borrow. So difference D is 1 and borrow 0. 1, 0, 1. So difference and borrow both are 0. And next condition, that is 1, 1. First with the 0 previous borrow. So 1, 1, 0. Again difference D as well as borrow both are 0. And last condition, that is 1, 1, 1. Difference D is 1 as well as borrow is also 1. So now from the truth table, we can easily identify the minterms for the difference D as well as for the borrow, and then we can prepare a K-map for the difference as well as for the borrow, and then we have simplified Boolean function which we can use to implement the logic circuit for the difference as well as for the borrow. Now first we check the minterms for the difference, meaning is the output difference D should be at the high level at various input combination. So first we check. So condition 0, 0, 1, we are getting difference D high. 0, 1, 0, again we are getting high output in difference. 1, 0, 0 and 1, 1, 1. For the 4 different input combination, that is 1, 2, 4 and 7, we are getting a high output in the difference D. This minterms we can use for the K-map. Same way for the borrow, if we check the minterms, we have first condition 0, 0, 1, we are getting high output in the borrow. 0, 1, 0, again we are getting high output. 0, 1, 1, again we are getting high output in the borrow. And last condition, that is 1, 1, 1, again we are getting high output in borrow. So same way like a difference in borrow also, we have 4 minterms for which we are getting high output, and that is 1, 2, 3 and 7. Now let us prepare K-map. First, for the difference, we have truth table. For the ready reference, we can identify the minterms in the truth table for which we are getting high output in the difference. So we have respective decimal number, that is 1, 2, 4 and 7. For the 3 input, we can prepare a K-map with different 8 cells. We have input variables AB on the horizontal plane, as well as we have third input variable, that is Bin on the vertical plane. We write as usual numbers and literals. We give decimal equivalent number from 0 to 7, and then we write a high or 1 in the respective cells for the minterms. So we have 1, 2, 4 and 7. So we have written 1 in respective cells. In all remaining cells, we have to write 0. Now we have to prepare groups for the minterms, but we can see that even pair is not possible. So we have to go for isolated groups. So isolated 4 groups can be prepared: first, second, third and fourth. And we write product terms for each group. Then we have a product term for the difference D, and it is equal to A bar B bar B in plus A bar B in bar plus A B B in plus A B bar B in bar. So we have 4 product terms, and the Boolean function is written in SOP form. So we have added all the product terms. Now same way, we can prepare a K-map for the borrow also. Again, we have truth table for the reference, and we can check the minterms for the borrow, and that is for the decimal number 1, 2, 3 and 7. So for the 3 variables, again we prepare a K-map with variables AB and Bin. We write literals for the respective cells. We give decimal number from 0 to 7 for each cell. Then we write minterms for which we are getting high output in the borrow. So that is 1, 2, 3 and 7. So we have written 1 in respective cells. In all other cells, we can write 0. Now we have a possibility of the pair. So we have first horizontal pair, and with the overlapping, we have second overlapping pair, and with the still overlapping, we have third pair, that is vertical. So we have 3 pair, and we can write the product terms for the each pair. So based on the grouping, now we have 3 groups, and we can write the Boolean function in SOP form with 3 product terms. So we have B out. We can write the product terms for each horizontal as well as vertical pairs. We have A bar dot B in plus A bar dot B plus B dot B in. So this way we have a Boolean function, simplified Boolean function ready for the borrow also based on the K-map. Now based on this simplified Boolean function, we can implement the logic circuit with the help of basic gates. First, let us have 3 inputs, that is A, B and B in, that is previous borrow. With the help of a NOT gate, we can invert all the 3 inputs to get A bar, B bar and B in bar. So we have 3 inverted inputs, A bar, B bar and B in bar, and we use NOT gate to have these inverted inputs also. Now first we prepare logic circuit for the difference. We have 4 product terms, so we know that we have to use 4 AND gates. Each product terms have 3 literals, so all the AND gates are with 3 inputs, and as per the Boolean function we can give inputs to each AND gate. Now because it is SOP form of Boolean function, at the end stage we have to use one OR gate to add all the product terms. So output of each AND gate we give as an input to the OR gate, and output of the OR gate we have a difference, that is our final difference D. Same way we can prepare a logic circuit for the borrow also. We have 3 product terms and each product terms are with 2 literals, so we use AND gates with 2 inputs. As per the Boolean function we give the connection. Again it is SOP form, so we use a OR gate with 3 inputs. Output of each AND gate we give as an input to the OR gate, and output of the OR gate, that is our final borrow. So we have 3 input terminals and 2 output terminals, that is difference D as well as borrow. So this way, with the help of basic gates, we can easily implement the logic circuit based on the Boolean function which we have derived from the CAMAP. From the truth table also, if we write a Boolean function in the SOP form, then we have difference D, that is A B bar B in bar plus A bar B B in bar plus A bar B in plus A B B in. Now we have possibility to simplify this Boolean function which we have written based on the truth table. Suppose from the first and second term, if we take B in bar common, then we have A B bar plus A bar B. Same way from the third and fourth term, if we take a B in common, then we have A bar B bar plus A B. Now we can see or we can identify that A B bar plus A bar B is nothing but a Boolean expression for the exclusive OR gate, and A bar B bar plus AB is nothing but a Boolean expression for the exclusive NOR gate. So we can write difference D as a B in bar A exclusive OR B plus B in and A exclusive NOR B. So again, if we introduce A exclusive OR B as X, then our equation for the D, that becomes B in bar X plus B in X bar, and this equation also indicates again an exclusive OR gate. So we can write D, that is a B in exclusive OR with X, and if we substitute the value of X, then it becomes B in exclusive OR with A, exclusive OR with the B. So simplified way we can write our equation, Boolean equation for the D, that is A exclusive OR B exclusive OR B in. So we can use, based on this simplified Boolean function, 2 exclusive OR gate, and we have A, B and B in 3 inputs, or we can use 1 exclusive OR gate with 3 input terminals. Same way, if we write Boolean equation for the borrow, with the help of truth table, and if we simplify, then we get a similar Boolean function, that is a bar b plus a bar b in plus b in. Now, based on both the Boolean function for the difference as well as for the borrow, we can realize the logic circuit for the full subtractor. We use one exclusive OR gate with the 3 input terminals. We give input, that is A, B and B in, and output of the exclusive OR gate that gives us the difference D. Same way for the borrow, we use 3 AND gates, and as per the Boolean function, we give input connections to the AND gate. We use one OR gate, and output of all the AND gates, that is product terms, that output is given as an input to the OR gate, and output of the OR gate we can take as a final borrow. So this way we can realize logic circuit for the full subtractor with the help of exclusive OR gate, AND gate, OR gate and NOT gate. Thank you very much for watching my video. Keep watching. Thank you very much.